Assalamu alaikum. Welcome to lecture 21 of data mining. So in the previous lecture, we had started talking about cluster evaluation, and we discussed why clustering evaluation is important. Um, there are a number of reasons why we would like to validate our clusters. So, so I can enumerate them once again. So basically, upfront, we don't really know whether natural clusters actually exist in a data set or not. But if you apply any clustering algorithm, it will still output clusters. For example, if you apply k-means on any data set, let's say even random data set, it will still give you k clusters. So we need to find out whether those clusters or clustering is relevant for the data set or not. So that's basically determining the clustering tendency. So another reason might be to find out the number of natural clusters in the data set, the K, that is an important input in many algorithms like k-means. We will also like to determine whether the clustering that we obtained matches closely with the similarity matrix. Remember, clustering is based on similarity matrix. So if the clustering that you obtain based on some similarity matrix have a strong correspondence, that means that your algorithm is good. Your algorithm has used the similarity matrix in a proper way. And then, of course, if you have external information, meaning that if you have labels, then you might want to compare your clustering to that external information. That's another important reason. And then, of course, there's a relative reason as well. So if you have multiple clusterings, you would like to compare the effectiveness or the quality of those clusters among themselves. So these are some of the reasons why we would like to do cluster validation. So we will discuss cluster validation today. I think that would be the main focus for today. We will probably finish it, or maybe if not, we will finish it quickly in the next lecture. All right. So any questions? All right. So let me start my screen. So we were discussing clustering validation or evaluation. So we have discussed the reasons why we would like to do cluster validation. And then the cluster validation approaches typically fall under three categories. We have unsupervised approaches, and then we have supervised approaches, and then we have what is known as relative, which is primarily applicable to comparing two algorithms or comparing two clusterings. So unsupervised, so no external info or labels. So so external labels are available. And then, of course, relative can be done in a supervised or unsupervised fashion. Let's start with unsupervised. So the measures that fall under unsupervised cluster validation are also called intrinsic measures. So they are intrinsic measures in the sense that they do not require external information. They can be computed directly on the data set and the similarity matrix for that data set or the similarity function for that data set. So we don't need any external labels for evaluating these measures. So these measures, there can be a bunch of such measures, and we typically categorize them further into two, those that are based on cohesion and those that are based on separation. So So, by as the name suggests, cohesion measures tend to quantify the cohesiveness or compactness of the clusters and the clusterings. Remember, whenever we talk about cluster validation, uh, we can validate the entire clustering that can consist of multiple clusters, or we can validate individual clusters. And sometimes even we can validate individual points. So how well is an individual point clustered? How well is an individual cluster? How well is the entire clustering? So it can apply at each of those three levels: individual level, cluster level, clustering level. ठीक है? And if we talk about cohesion, as I said, cohesion quantifies the compactness or the closeness of the objects within a cluster, while separation quantifies uh, the separation or divergence of objects between clusters. So these measures would kind of quantify these two things. And they, as I said, there are different ways of doing this. And we won't be going into all the different methods that will be proposed. I'll just give you some sample examples and then we'll move on. Before we go there, in general, if you want to uh, find the validity or of an entire clustering, you can express this in general as a summation over all the clusters. I is equal to 1 to k is the total number of clusters of the weighted validities of each cluster. Weight wi for each cluster multiplied by some validity measure that is computed for each cluster. ठीक है? So VAL is a validity measure, let's say intrinsic measure. It could be cohesion, it could be separation, or it could be both. Hybrid भी हो सकते हैं. That is computed for a cluster, one cluster, और उस वन क्लस्टर की जो वैलिडिटी निकाली उसका कोई वेइंग फैक्टर कोई हो सकता है डिपेंडिंग ऑन द साइज ऑफ द क्लस्टर. फॉर एग्जांपल, you aggregate it, you get the validity for the entire clustering, which is on the left hand side. Actually, इसको एक step further भी लेके जा सकते हैं. So validity is could be sum I is equal to 1 to n. So wi validity for each object xi. ठीक है? So इस तरह भी आप कर सकते हैं. If you have a validity measure that can be applied to each object, then you can aggregate that. Usually aggregate weighted जो होगा mean होगा. Wi's would simply be the basically 1 and 1 over n, basically the total number of objects in the clustering. ठीक है? So you can combine validity measures in this way to find the validity of the entire clustering. So if you can compute the validity of one cluster, aggregate it for all clusters. If you compute the validity of one object, aggregate it for all objects. Okay. So what are some of the validity measures for clusters? Okay. So as I said, we can have cohesion based and we can have separation based, and depending on the type of the cluster, they could be prototype based or density based or graph based. You can have different measures. So I'll just discuss one or two measures. So cohesion में basically जो होगा, for example, this could be the sum of distances of objects in a cluster. ठीक है? So pairwise distances of objects within a cluster. So that could be, अब ये distances and ये similarities भी हो सकती हैं. Remember, if you use similarities, then higher value is better. If you use distances, then lower values is better for cohesion. Similarity, dissimilarity, you have to keep that in mind. If you are using similarity, then higher values are better for cohesion. If you are using dissimilarity, then lower values are better for cohesion. Mm. So what else? You can also use, by the way, the sum of pairwise distances, this is more of graph-based notion of course, you can apply it to any data set, but it comes from the graph-based notion of clusters. The other could be sum of distances of each object with, yeah, from the cluster's centroid or uh, slash medoid slash mean. So this assumes that the clusters are prototype based. Okay. So these are again cohesion measure. This is a cohesive measure. Cohesion measure हर एक cluster के लिए निकल सकता है. By the way, ये हर एक object के लिए भी निकल सकता है. For any object, you can compute its distance uh, from its cluster mean. If that distance is large, then it means that it is not well clustered. If that distance is small, it means that it is fairly goodly clustered. तो रिमेंबर हमने पीछे कहा था कि ये वैल्यूज इंडिविजुअल के भी निकल सकते हैं, क्लस्टर्स के भी निकल सकते हैं, फॉर द एंटायर क्लस्टरिंग यू एग्रीगेट. ठीक है. So I think you can have other measures as well. I don't want to go into details. If you, by the way, this part I'm primarily covering from the intro to DM book, which is section chapter 7.5. ठीक है. ये मेरे पास यहाँ खुला भी I think. So this is the chapter open here. This chapter is actually freely available on the web, although I have the licensed version of this book. But ये chapter freely available है, web पे PDF available है. So I am going to cover from this section primarily this part. दूसरी book में भी है, but this one is much better than the other book. Mm. Okay, what about separation? ठीक है. So separation में you can take the sum of distances of objects in one cluster to those in another cluster. ठीक है. So this would of course based on graph based notion of clustering, because आप assume करें each object is a node, and uh, if two nodes are connected, there is an edge in the graph. So this is one way of quantifying separation. In this case, since we are using distances, larger values are considered better. ठीक है. Similarities होती तो then smaller values uh, would have been considered. By the way, sum of distances between two clusters है ना ये. So larger values are better if you are using distances, and if you are using similarity, then smaller values are considered better. Okay. So if you have a prototype based notion of clustering, then you can take sum of uh, or not sum, it will simply be difference डिफरेंस भी रहने डिस्टेंस कर लेते हैं डिस्टेंस बिटवीन सेंट्रॉइड्स ऑफ टू क्लस्टर्स ठीक है आपके पास दो क्लस्टर हैं दोनों सेंट्रॉइडल डिस्टेंस है ये so this is also between two clusters and higher values are considered better if we are using distances so this is prototype based notion में ठीक है and of course you can have many other measures as well in the book you will see that there is a table in the book I think some table 7.5 I guess उसमें काफी measures दिए हुए हैं वो आप बाद में इसको देख सकते हैं there are some measures that are hybrid as well so that basically hybrid cohesion separation together they use the notion of cohesion as well as separation so given the measure that we have written above you can easily create hybrid measures for example एक hybrid measure ये हो सकता है कि so we have computed for example the sum of distances of each object from its cluster mean ठीक है so that is cohesion so actually usually if you want to make a hybrid usually it will जैसे हमने ऊपर पीछे लिखा था wi into validity into ci तो usually जब आप hybrid बनाएंगे तो you can think of hybrid as let's say one measure being cohesion validation cohesion हो गया और जो weight है वो आपका कोई separation की concept आ रहा है इसमें weighing scheme separation आ रही है vice versa weighing scheme cohesion का concept आ रहा है और validation में cohesion का concept आ रहा है you combine both of them so in a very naive sense you can have a measure that is cohesion divided by separation ठीक है so this could be a measure for a cluster so in this case if you're using similarities higher values of this ratio would be better because cohesion high होगी और separation cohesion की similarity high होगी separation की similarity थोड़ी होगी this ratio would be high so this high ratio would become high if either cohesion is high or separation is low or both ठीक है so these measures would typically be as I said hybrid measures any questions so far one important hybrid measure that I'm going to discuss which is separate from the two measures, the four measures that I discussed earlier, is the silhouette coefficient. Silhouette coefficient. The silhouette coefficient is computed for an object. But as I mentioned earlier, you can aggregate it for an entire cluster and you can aggregate it for entire clustering. Okay. So the silhouette coefficient for the ith object, so Si, let me write the formula first. So Bi minus AI divided by max, of course, ये ऊपर difference है of AI and Bi. Okay, so what is AI and Bi? So we are talking about a specific object. So ith object in the clustering. ठीक है. So let's say आपका xi है. This is your object. So we're trying to find how well this object is clustered in the clustering. So what is AI? So AI is basically the average pairwise distance. I'm using distance here. Distance of xi with other objects in the same cluster. Object xi एक क्लस्टर में है, उस क्लस्टर में और ऑब्जेक्ट्स भी हैं, तो उसी क्लस्टर के अंदर जो बाकी ऑब्जेक्ट्स के साथ जो डिस्टेंस xi का बनता है उनका एवरेज. ठीक है. सो इफ दे आर लेट्स से 10 ऑब्जेक्ट्स इन ए क्लस्टर और xi उसमें एक है, देन यू विल टेक 9 डिस्टेंसेस और 9 डिस्टेंसेस को 9 से डिवाइड कर देंगे, सम करेंगे और 9 से डिवाइड कर देंगे. सो दिस इज द एवरेज. So obviously, since this is distance, smaller value generally would be considered better. So this is a measure of cohesion. Smaller values would be considered better. ठीक है. So what is BI? BI में so we actually have the min of something. ठीक है. So let me write the statement for the what min is. It is basically average distance of xi to objects in other clusters. ठीक है. सो xi एक क्लस्टर में है, राइट. और क्लस्टर्स भी होंगे. सो लेट्स से एक और क्लस्टर मैंने लिया, तो xi का पेयर वाइज डिस्टेंस विद दिस क्लस्टर, अदर क्लस्टर, वो निकाला, एवरेज कर लिया. पर जरूरी नहीं उससे 2 क्लस्टर्स होंगे, मे बी दे आर 10 क्लस्टर्स हैं. तो सारों के लिए आपने निकालना है, उन सारों में से जिसका सबसे थोड़ा डिस्टेंस आ रहा है वो ये बी आई है. ठीक है. सो दे माइट बी मोर देन 2 clusters in a clustering. So with all the other clusters you find the average distance, और जिसका सबसे थोड़ा है वो बी आई है. ठीक है. So this is a measure of separation between two clusters, a measure of separation. और अब हमारे पास जो ओवरऑल हाइब्रिड मेजर बना है, जो मैंने ऊपर फॉर्मूला लिखा है, वो बेसिकली बी आई माइनस ए आई divided by, of course, whatever max value you have between the two. Max है कि min है min ai and bi. ठीक है. So let's look at this measure. So numerator में bi minus ai है. So for an object I, if it is properly clustered, bi would definitely be larger than ai. Ai क्या है? Average distance to objects within its cluster. Bi average distance to objects in the nearest other cluster. So bi should definitely be greater than ai if it is properly clustered. So ऊपर positive value होगी, नीचे of course normalization है simply. So we normalize with the smallest ai or bi, जो भी बड़ा इसमें है, so that we get a maximum value of 1. तो इसकी जो range है si की is basically -1 and 1. ठीक है. Of course, as I said, minus values means that the object is not clustered properly. ठीक है. Positive values, it means that object is clustered properly, and of course higher positive values means that the object is uh, quite properly clustered. ठीक है? या ये मैक्स है एक्चुअली, डिनोमिनेटर में नॉर्मलाइज कर रहे हैं ना, बड़ी वैल्यू से नॉर्मलाइज करेंगे, जो भी बड़ी वैल्यू है. सो फॉर एग्जांपल इफ बी इज लार्जर देन ए, तो नीचे बी होगा, बिकॉज थोरेटिकली ए जीरो भी हो सकता है, ए आई जीरो हो सकता है, जीरो होगा तो बी आई और बी आई डिवाइड होगा तो गेट ए वैल्यू ऑफ वन. क्या बी इज जीरो, ऊपर जीरो होगा तो ऑफकोर्स यू गेट ए वैल्यू ऑफ जीरो. सो बी इज इक्वल टू ए, इफ बी इज लेस देन ए देन यू गेट ए नेगेटिव वैल्यू. और डिनोमिनेटर आपके पास जो भी स्मॉल वैल्यू है, स्मॉल वैल्यू है जो भी, आई थिंक मिनिमम भी ठीक थे. ओके, इट इज मिन, सॉरी. ठीक है, आई जस्ट गेटिंग अ बिट कंफ्यूज देयर. ठीक है. All right, so that's a normalization. Denominators, in any case, a normalization. We just want to make sure that the value upper and lower limits are +1 and -1. ठीक है. So so you can get a value for each point, और actually इसको use करके आप एक visualization बना सकते हैं, बड़ी nice visualization बन जाती है. तो let's say आपके पास 2D object है, तो you can actually plot each point and maybe the size or maybe the color of the plot, the point can show the value of s. ठीक है. So let's say साइज से मैं बात करता हूँ, तो बड़ा साइज है तो इसका मतलब दिस ऑब्जेक्ट इज प्रॉपर्ली क्लस्टर्ड, छोटा साइज है दिस ऑब्जेक्ट नॉट प्रॉपर्ली क्लस्टर्ड. या कलर से आप कर सकते हैं, डार्क कलर है विच मीन्स दैट द ऑब्जेक्ट इज लेट्स से नॉट प्रॉपर्ली कलर, लाइट कलर है तो ऑब्जेक्ट प्रॉपर्ली कलर. तो आप एक 2D आप प्लॉट बनेगा तो यू हैव ऑल दीज पॉइंट्स, और बड़ा अच्छी विजुअलाइजेशन बन जाती है कि आपका कौन से पॉइंट्स क्लस्टर्ड हैं कौन से नहीं है. And of course, since this is for each object, you can aggregate it for each cluster. Aggregate simply आपने sum लेना है और divide by the number of objects, and also you can aggregate for the entire clustering. ठीक है. And just to reiterate, let's say आपके पास xi ये था और ये एक cluster में था, xi जो ai है इसी cluster के अंदर वाला distance है, और जो bi है इस cluster के दरमियान distance है. This is bi और वो ai. Of course, this is all averaging, not one distance but average. ठीक है. Any questions? All right, so let's move on. So as silhouette coefficient is a hybrid measure, it's an unsupervised measure. Hybrid in the sense that it is cohesion and separation based. It can be applied to individual objects, and from those individual objects you can compute for the entire cluster or the entire clustering. Okay. Uh, so we have looked at some unsupervised measures. So one, we can use such measures to find, for example, the number of clusters k, the natural number of clusters k in a clustering. ठीक है? And of course, this is it's not going to always work, but you can try it out. So let's say आपका कोई कोहिजन का कोई मेजर है. लेट्स से आपने प्लॉट किया कोई कोहिजन का मेजर. कोहिजन का मेजर should, what is cohesion, let's say distance based है तो smaller values are better, right? So जब आप let's say आप प्लॉट कर रहे हैं x एक्सिस पे k है, नंबर ऑफ क्लस्टर्स, यहाँ कोई भी कोहिजन का मेजर है, तो प्लॉट वुड बी समथिंग लाइक दिस. ठीक है? द वैल्यू वुड monotonically decrease. So in many, or I would say in some application, you can find the natural number of clusters k by finding kinks or regions in this plot at which the slope changes significantly. Okay? So as I said, the cohesion measure could be SSE, for example, or it could even be the silhouette coefficient. Silhouette coefficient में भी ऊपर जो basically हमारा silhouette coefficient of course कर्व उल्टा होगा, मैक्स हम देखेंगे. कोहिजन में of course ये कर्व नीचे आ रहा है. ठीक है? Let me draw the curve again. So let's say आपके पास कुछ कोहिजन की मैं बात कर रहा हूँ, ये कर्व आ रहा है तो एक कहीं सिग्निफिकेंट चेंज इन स्लोप आया, इधर चेंज इन स्लोप आया. So this may be a potential natural number of clusters in your data set. But इसके बाद आपकी change in cohesion was significant. So this may be a natural number of clusters in your data set, and you can further evaluate this through visualization. Oftentimes kinks ढूंढना थोड़ा सा मुश्किल हो जाते हैं real world data sets, but for some application ये king well defined होता है, quite well defined. तो इसका मतलब है कि आपके natural clusters आप easily आप निकाल लेते हैं through this graph. Of course you might want to try this out for various measures. जैसे आपने कोई कोहिजन मेजर, जैसे जो के मीन्स का मेजर है वो अप्लाई करके देख लें, या सिल्हूट कोफिशिएंट अप्लाई करके देख लें. दो तीन ट्राई करके देखें उससे के क्या आता है. इफ यू गेट कंसिस्टेंट केस, इसका मतलब है नेचुरल नंबर ऑफ क्लस्टर्स उसके उतने ही हैं उस डेटा सेट के. तो ऑफ कोर्स जैसे मैंने कहा कि आप सिल्हूट लेंगे तो वो ग्राफ ऊपर जा रहा होगा यूं करके, उसमें कहीं किंक, कोई इधर कहीं सिग्निफिकेंट कोई चेंज आई है, वो आपका होगा. सिल्हूट कोफिशिएंट वुड गिव यू ए ग्राफ दैट इज इंक्रीजिंग. So the natural number of clusters k so can be estimated by uh, you can say kinks in a uh, you can say intrinsic measure versus k graph. ठीक है? So intrinsic measure could be silhouette coefficient, sum of squared error, sum of distances from the center of a cluster, and so on. Okay. Uh, so continuing our discussion on unsupervised evaluation. So remember, we typically, uh, before we even start clustering, we usually have a proximity measure. Proximity measure could be a dissimilarity matrix or a similarity matrix or a dissimilarity function or a similarity function. So proximity proximity function or matrix. So this could be either similarity. By the way, proximity is a general name. It could be similarity or dissimilarity. ठीक है? So we usually have this because without this you can't do clustering. So one way to evaluate whether a clustering that you have done through an algorithm matches this matrix is you can find the correlation between the clustering that you have obtained with the similarity matrix. So let's do this with similarity matrix. So let's say we have a similarity matrix. Let's say, let me call this S. So S, as you know, would be a n by n symmetric matrix where each cell in S would be the similarity between 2 points or 2 objects in the data set. Okay? So this is a similarity matrix. So we will create another matrix which I call the clustering matrix. See, this is also an n by n matrix. और इसकी characteristics क्या है? This is also an n by n matrix. So this is also n by n. ठीक है? So what is this clustering matrix Cij? One cell in this matrix, this cell we will set as 1 if object I and j belong to the same cluster. Remember, you have done a clustering. So after doing the clustering, you know which 2 objects are in the same cluster. So good, you can then create a clustering matrix. So if object x and y, x and j, sorry, object I and j are in the same cluster, you should have a 1 there in the matrix. Otherwise, it will be 0. Okay? So naturally, if 2 objects are in the same cluster, if they correspond well with the similarity matrix, they should have a strong similarity also, right? Xi, so Sij should also be large if Cij is 1. And if Cij is 0, Sij should be small, right? So, so we have now 2 matrices. Each of them has a number of values. So we can actually compute the correlation between these 2 matrices value by value. So you can use any of the correlation measures that we have studied before. So you can, for example, use the Pearson correlation coefficient, for example, or yeah, I think Pearson correlation coefficient is more than good because both values are numeric. तो Pearson आप use कर सकते हैं. ठीक है? So if you get a correlation coefficient that is close to 1 or high above 0, then it means that the clustering that you obtain does matches well with the similarity matrix. It kind of validates your clustering algorithm. So do you get this point? So obviously if Sij similarity is high, then Cij should be 1. इसका मतलब है 1 और हाई वैल्यू और Sij सिमिलैरिटी लेट्स से नॉर्मलाइज है वो भी मैक्सिमम 1 ही होगा. तो इन दोनों में कोरिलेशन होनी चाहिए, स्ट्रॉन्ग कोरिलेशन होनी चाहिए. So you can use a correlation measure. You can even use a similarity measure like Jacob coefficient also. Jacob's coefficient, yeah, simply adding the differences of the corresponding cells in the 2 matrices. Any questions? Oh. All right. So So in this way, you can determine whether your clustering has done a decent job in translating the similarity matrix into clusters. And extending this same idea, you can actually use the similarity matrix to find out if there is natural clustering tendency in the data set. Of course, this is kind of much harder, but it's more of a visualization thing. So, तो similarity matrix आपके पास let's say है, उसमें values हैं, values let's say similarity है तो it will range from 0 to 1. So you can create a 2D uh, similarity matrix 2D होता है ना, you can create a pixel map. If a value is large close to 1 उसको dark कर दें, if the value is small you can make it lighter. तो आपके पास 2D मैप बन जाएगा. ठीक है, अब उस मैप को आप rearrange करें visually. If you can get all darker points in one block here and another block here and another block here, of course this is the ideal scenario, then it means that your data can be naturally clustered, and if you get 3 blocks then there are only 3 clusters in it. ठीक है, मतलब ये ब्लॉक मैट्रिक्स आपके जो पिक्सेल्स के ब्लॉक्स बन जाएंगे, ये एक बॉक्स है, ये दूसरा ब्लॉक है, ये तीसरा ब्लॉक है, और मे बी जैसे चौथा ब्लॉक है. All of these blocks are dark, the rest of the blocks are light. Remember, dark means that similarity is high. Of course, ये करने के लिए आपको रोज हर एक रो ऊपर नीचे करने पड़ेंगे so that you get this block diagonal structure, which is of course not very easy, it's not trivial, but you can take a quick look and see कि इस तरह हो सकता है that you get an idea कि ये clusterable है कि नहीं है data set. Just take the similarity matrix, plot it as a 2D scatter plot with each point shown as a in terms of darkness. If its similarity is high, it should be darker. If its similarity should be lower, और फिर इसको आप tweak करें कि can you get this structure? So if you get this well-defined structure, then it means that your data is highly clusterable. But as I said, this is more for visualization, and for many practical applications इतना आसान नहीं है. It's not easy to do this. For some data set आप कर लेंगे, but तो more appropriate वही हैं जो हमने पीछे measures देखे हैं. You can use this similarity between the similarity matrix and clustering matrix. So that will give you a number. Visualization नहीं है. So that is much easier. All right. So I think with that we conclude the unsupervised approach. So now let's look at the supervised approach. So previously we were entirely discussing unsupervised, no external information. Here we have external information. And what is that external information? You have labels which are essentially class labels essentially for the objects in the data. So one obvious question is, if you have class labels for the objects in the data, why do you need clustering? So this is only for testing purposes, right? Remember in classification, you kept some testing data set. So if you have a small data set over which you have the labels, तो वो आप टेस्टिंग के लिए रख लें, बट आपका जो बड़ा डेटा सेट है वो अनलेबल्ड है, उसको आप क्लस्टरिंग करें, उसकी क्लस्टरिंग फिर कंपेयर करें. So actually if you have a small data set for testing purposes and you're testing your algorithms, so once you have selected an algorithm, then you can go ahead and apply your algorithm to any unlabeled data set. Okay? So for this purpose, as I said, you need labeled data set. You need to have labels for each object, such saying that it belongs to this cluster or this class or not. So in this sense, it is identical to classification, and the measures in this category are also related to classification. वही measures यहाँ भी use होंगे. ठीक है. इसके अंदर भी further actually दो categorization है. Let me write those out. So classification oriented approaches हैं और एक फिर similarity oriented approaches हैं. या कोरिलेशन ओरिएंटेड, जो हमने पीछे भी देखी थी, बट दैट वाज अनसुपरवाइज, ये सुपरवाइज्ड है. लेट्स फर्स्ट स्टार्ट विद क्लासिफिकेशन ओरिएंटेड. ठीक है. हम्म. अब इसमें वही सारे क्लासिफिकेशन मेजर्स यूज हो सकते हैं, बट इन द केस ऑफ क्लस्टरिंग हम तीन चार को ज़्यादा प्रिफर करते हैं. उनमें से एंट्रोपी है, प्योरिटी है, एंड देन ऑफ कोर्स प्रिसीजन, रिकॉल एंड एफ मेजर. ठीक है. So let me um, show you the setting. So what happens? You are doing clustering. You have the clusters of the object which have labels. Let's say आपने एक cluster one बना लिया. उसमें let's say तीन objects आए. ठीक है. और उसके labels भी आपके पास हैं. तो लेट्स से उसका लेबल ए था एक का, और एक का बी था, और एक का सॉरी दूसरा भी ए था और एक का बी था. ठीक है. और लेट्स से क्लस्टर टू में आपके पास जो ऑब्जेक्ट्स आए उसमें एक बी था, एक बी था और एक ए था. सो दिस बी बी एज ये लेबल्स हैं. और जो सी वन सी टू है, ये क्लस्टरिंग आपके क्लस्टरिंग एल्गोरिथम ने की है विदाउट लुकिंग एट द लेबल्स. सो एल्गोरिथम हैज क्लस्टर्ड दीज 6 पॉइंट्स एंड क्रिएटेड टू क्लस्टर्स. अब हमारे पास लेबल्स थे, हमने उनके लेबल्स भी साथ लिख लिए, वो मैंने यहाँ शो किए हुए हैं. So based on these labels, now you can compute these classification-oriented measures. So इस case में, for example, let's say if I talk about entropy, so what is the entropy of cluster one? So cluster one में आपके पास दो objects हैं, एक class के और एक object दूसरे class का. तो entropy would then be, जैसे entropy का formula होता है -2/3 into log 2/3, then -1/3 into log 1/3. ठीक है ना. ये इसकी एंट्रोपी एक क्लस्टर की आ जाएगी. इसी तरह क्लस्टर टू की भी आ जाएगी. उसकी भी बाय द वे यही है, उसमें दो बीज हैं और एक ए है. तो वो भी -2/3 एंड -1/3 होगी. ठीक है. लेट मी सी. तो ये निकाल भी दिए इसने 0.63. ठीक है. एक्चुअली एंट्रोपी इस डेटा सेट में दूसरे की भी सेम है, दूसरे क्लस्टर की भी सेम है, C2 की भी 0.63 है. ठीक है. So what is the entropy of the entire clustering? Of the entire clustering, this is simply the weighted average. तो दोनों क्लस्टर में जो आपका है, so this would be 3/6 into 0.63, 3/6 into 0.63, which is of course 0.63. ठीक है. So इस तरह आप निकाल सकते हैं if you have label data set. उस डेटा सेट को क्लस्टर करें without looking at the label, then write down the labels and see their entropy within each cluster, and then aggregate it for the entire clustering. ठीक है. Okay, so next is purity. So purity of a cluster C1, let's say, is basically the maximum uh, maximum fraction of objects, इसको किस तरह लिखना है, एक सेकंड. I'll write it like this: max of basically the fraction of objects belonging to class 1, class A. यहाँ दो थे हमारे पास. Let's say I call that PA and PB. ठीक है. So आपके पास max है. What is the number of points that belongs to class A? That's 2/3, 2/3, और ये 1/3 है. So this would 2/3. Purity would be 2/3 for cluster 1. Similarly, purity of cluster 2 would also be 2/3. बिकॉज इसमें जो हाईएस्ट क्लास आ रही है, जो मोस्ट प्रोबेबल क्लास है, उसका फ्रैक्शन 2/3 है. एंड अगेन इसकी एग्रीगेशन उसी तरह ही होगी. यू एग्रीगेट प्योरिटी ऑफ द एंटायर क्लस्टरिंग, इट बेसिकली 3/6 into 2/3 plus 3/6 into 2/3, which is 0.666. ठीक है. So one difference between the two: purity higher is better, entropy lower is better. Remember, entropy 0 means that it is homogeneous. So 0 would be best, purity 1 would be best. Of course, entropy का upper limit कोई नहीं है. Upper limit would depend on the number of clusters, classes. ठीक है. But purity की upper limit हमेशा 1 है, because the probability is a fraction. और of course lower limit इसकी 0 ही है. Purity you can say normalized between 0 and 1. और जो entropy थी, this would typically lie from 0 and a large value, infinity कह लें in general. Although some upper limit, which is not necessarily infinity, some I would just say some other value, some value n. ठीक है. So entropy and purity are quite commonly used for doing supervised evaluation of clustering. So accuracy या और जो मेजर्स एंड क्लासिफिकेशन के लिए वो नहीं यूज होते, और ये ज़्यादा यूज होते हैं. एंड समटाइम्स वी विल रिपोर्ट मल्टीपल मेजर्स. एक मेजर नहीं रिपोर्ट करते हैं, मल्टीपल करते हैं. प्योरिटी भी कर लेंगे, एंट्रोपी भी कर लेंगे, एंड सो ऑन. एंड देन ऑफ कोर्स यू कैन आल्सो रिपोर्ट, जो मैंने कहा, प्रिसीजन, रिकॉल और एफ मेजर. ये वही मेजर्स हैं जो क्लासिफिकेशन के लिए भी यूज होते हैं. डिड वी कवर दिस बिफोर? ब्रीफली डिस्कस किया था शायद हमने. So what is precision? So what is the precision of cluster C1? So cluster C1 should uh, so so it has A and B. दो A और एक B है, ठीक है ना. So and B are actually the true labels. तो उसमें से, let's say if we say this cluster 1, so actually precision would have to be computed for each label separately. So for, let's say, class A, so what is the precision that we have retrieved A in cluster 1? And similarly, you have to compute precision in cluster 1 for B. So दो values आएंगी for each cluster. So in this sense, it is kind of more involved. Although ये combine करने के कुछ तरीके available हैं, but it's kind of difficult to understand sometimes. ठीक है. तो अब ये for A का क्या होगा? इसका A दो दफा आया है, तो so A टोटल हमारे डेटा सेट में कितने हैं? एक्चुअली इसमें हमारे पास टोटल इसमें हमारे 3 आए हैं, उसमें हमने 2 निकाले, तो इसका जो प्रिसीजन इतना होगा. ठीक है. इसी का रिकॉल फॉर ए C1 फॉर ए टोटल हमारे पास 3 थे, और एक्चुअली ये सारे वही नंबर्स आ रहे हैं एक्सप्लेनेशन थोड़ी सी। टोटल हमारे पास एज 3 हैं, जो ट्रू एज 3 हैं, इसने 2 निकाले हैं, तो ये भी रिकॉल भी 2/3 है, प्रिसीजन भी 2/3 है, रिकॉल भी 2/3 है। व्हाट अबाउट प्रिसीजन C1 फॉर B? So B is basically 1/3. What about recall for C1B? C1 में basically एक ही निकाला था, again this is 1/3. तो इस तरह आपको क्लास वाइज निकालना पड़ेगा, and then you can aggregate them class wise. Combined aggregates के एक दो तरीके हैं, but they are not very popular as well as they are not very interpretable. Class wise आप इसको combine कर सकते हैं. Of course you can combine them using final combination भी कर सकते हैं, use F major. F major for example for C1 and A निकाल लेंगे, which is of course as you know precision into recall divided by 2 into precision into recall. Two into precision divided by precision plus recall. So, so precision plus recall. तो ये F major का फॉर्मूला है. Okay, so you can combine both precision for a given class. हर क्लास का सेपरेट होगा. And this of course is for the for a particular cluster. तो आपने क्लस्टरिंग को कंबाइन करना है, तो वो वेटेड एवरेज ही चलता है यहाँ भी, जो पहले किया, नंबर ऑफ ऑब्जेक्ट्स इन क्लस्टर जो टोटल नंबर ऑफ ऑब्जेक्ट्स. So these are the main measures that are used in the classification oriented approach for supervised evaluation. You can use entropy, you can use purity, you can use precision recall as measure. Entropy and purity are generally quite popular. दोनों ही दिए जाते हैं जब भी देते हैं. So entropy, smaller values are better, purity, higher values are better. Of course, precision recall and F measure higher values are better. So any questions? So finally, so let's briefly look at the last one, which is similarity oriented or correlation oriented approaches. Okay. So remember when we did similarity based approaches before, हम compare करते clustering matrix with similarity matrix. तो यहाँ हम कंपेयर करेंगे क्लस्टरिंग मैट्रिक्स विद क्लास मैट्रिक्स, क्लास जो ट्रू लेबल्स हैं. तो क्लस्टरिंग मैट्रिक्स वही जो पहले था. लेट्स से मैं उसी को क्लस्टरिंग मैट्रिक्स सी है, तो इसका क्या हमने डिफाइन किया था, सी आई जे इज इक्वल टू 1 इफ आई एक्स आई एंड एक्स जे आर इन सेम क्लस्टर. ठीक है, एंड जीरो अदरवाइज. तो ये था. अब दूसरा हमारा जो मैट्रिक्स है वो, उसको मैं क्लास मैट्रिक्स कह दूंगा. इसका नाम इसको I don't know, let me call it L. So this is based on the two labels. ठीक है. So now Lij is equal to 1 if xi and xj have same label. ठीक है, meaning that they belong to same class, they should belong to the same class. तो आपके पास अब दो मैट्रिसेस फिर आ गए. सी तो क्लस्टरिंग के बाद आया, और एल जो है आपका डेटा सेट लेबल था वहां से आया. बोथ मैट्रिसेस आर एक्चुअली 0 1 मैट्रिसेस. पहले हमारे पास सी 0 1 था, और जो सिमिलैरिटी मैट्रिक्स था इट वाज अ कंटीन्यूअस बिटवीन 0 एंड 1. ठीक है. सो बोथ ऑफ देम आर 0 1 मैट्रिसेस, बाइनरी मैट्रिसेस. तो आप इवन बाइनरी जो सिमिलैरिटी मेजर्स भी अप्लाई कर सकते हैं टू कंपेयर दीज टू मैट्रिसेस. So for example, you can use a Jacob coefficient, which we studied when we were discussing association mining to determine or compute similarity between C and L. So this is cell by cell or element similarity of C and L. So if you have a 1 in a particular cell in C, ideally you should have a 1 at that particular cell in L. If not, then you have uh, a dissimilarity, and the similarity value, this Jacob coefficient will become larger. ठीक है? तो ये both matrices binary हैं, so you can apply any binary similarity measure technique. Jacob coefficient हो सकता है, Sorensen dice हो सकता है, कोसाइन भी लगा सकते हैं, कोसाइन सिमिलैरिटी भी लग सकता है, सिंपल मैचिंग कोफिशिएंट भी लग सकता है, और यू कैन इवन अप्लाई कोरिलेशन कोफिशिएंट, पियर्सन कोरिलेशन कोफिशिएंट, ऑल्दो आई थिंक उससे it's much easier to use the simpler techniques. ठीक है, so if you are using a similarity, then higher similarity would mean that you have a good clustering, lower similarity would mean that you have a poor clustering. So I think that essentially brings us to the end of cluster validation. Uh, are there any questions? Any questions? So in the next lecture, we will start talking about outlier or anomaly detection. Uh, so that might take 1 to 2 lectures. And then we have some additional topics. So those additional topics I'm still kind of undecided. So I had initially proposed that we'll discuss temporal data mining, but let me see what seems more appropriate now, because we will have about 4 to 5 lectures remaining after outlier detection. So देखते हैं, if you have any suggestions on topics, you can always send them to me. तो हम वो cover कर लेंगे. So there are lots of things that could be covered. So temporal analysis could be covered. For example, graph mining could be covered. Web mining can be covered. उसमें भी graph mining आ जाती है, by the way. Uh, so so these things are all options out there. So वो हम देख लेंगे क्या cover करना है हमने बाद में. आउटलायर एनालिसिस नेक्स्ट मेन टॉपिक है, विच इज़ अवेलेबल इन दीज बुक्स. जो एडिशनल टॉपिक्स मैं जो बात कर रहा हूँ वो इन बुक्स में नहीं है, वो एडिशनल हम टॉपिक्स डिफरेंट बुक्स से या डिफरेंट जगहों से लेंगे. ठीक है. So I think if you don't have any questions, we can end today's session.